Hi, I'm Eduardo Gil, student of the Sustainable Biomaterials Science Doctoral Program in the University of Guadalajara. In this poster, I'm presenting my thesis work. Well, let's focus on four things. First, Persea americana, that's the scientific name of avocado tree. Cellulose nanofibers, acrylic epoxidized soybean oil, scarred AASO, and nanocomposites. Well, because the main objective is the elaboration of nanocomposites based on AASO polymeric matrix reinforced with cellulose nanofibers extracted from avocado tree branches. Why avocado tree branches? Well, that's because Mexico is the largest avocado producer, and avocado trees are subjected to different kinds of prunings. So residual avocado branches become an agro-industrial residual biomass. And those branches are lignocellulosic material from which cellulose could be isolated through pulping and bleaching. Pulping and bleaching is the first step in our methodology. Then it's the geochromite refining, temp oxidation, microfluidization, and then an amination reaction with the diethylene triamine. And then mixing those aminated cellulose nanofibers with AASO. And finally, UV casting of nanocomposites in printed molds. So once we got the high purity cellulose, at least 90% of alpha cellulose, was the next step, that is refination in a geochrom mill. This will lead the elementary fibers to get exposed from microfibers, making them more susceptible to that oxidation, temp oxidation, and helping cellulose nanofibers extraction by microfluidization. But this is how it looks, the cellulose nanofibers. But another reason we choose tempo oxidation is because we can use the carboxylic groups generated in this reaction to graph diethylene triamine. And well, this is the reaction. And first we perform the amination only on tempo oxidized cellulose, let's call it TOC, but not yet in cellulose nanofibers. And the FTIR spectra shows that carboxylic groups are generated in temp oxidation, and then how that peaks move to another zone that indicate the nitrogen-hydrogen bending vibrations of the amide bond on the new ATOC. And well, that is expected that this ATOC reacts with the epoxy rings in AASO and get better compatibility between them. This is a proposed interaction. And then, oh yes, this is how we print the molds. First, we design them in Tinkercad, then we slice it, and that's how it looks in the mold printed. And then we use that mold to to put ASO and then take it to the UV casting. And that's a specimen of ASO. We repeat this UV casting process with the ATOC, and we obtain a ATOC ASO composite. And that's how it looks. As we can see in the transversal area, there is some space on fillet. And well, part of our hypothesis is that we can obtain homogeneous composites if we replay this process with cellulose nanofibers. Well, I think that's all for now. And if you want to contact us, any suggestion are welcome. Those are our emails. And see you later. Thank you for your time. Bye bye.